All right, today we are going to continue what we did yesterday for the most part. Bell work is a really good reminder of those different things that we did yesterday and making sure we're on the right path. We're going to add something a little bit different today. Composite functions, they seem a little bit strange, and they are. You just got to get a feel for them. Once you've done them a couple times, you'll get better. I think it's definitely a thing today that is a repetition thing. The first time you do it, it's going to look really strange. By the fifth or sixth time you've done it, it'll be fine. Okay. I even went back during passing period and added some extra problems in there, just that way we could practice a little bit more together instead of just cutting you loose. All right, that's what we're doing today. Tomorrow is going to be very similar concepts, so if you're still lost after today, you'll get a little bit better tomorrow and continue to progress as we go. Okay, Thursday we'll review and then go from there. So we're not doing a whole lot more topics after we get through today. All right. So in bell work, we're finding the exact value of the expression without using a calculator. We're going to do this in radians. I didn't specify that, but we will. All right. So looking at number one, we're finding the exact value. Remember what this means. This inverse sign right here. Okay. Inverse sign means I am looking for where on my unit circle is sine going to get me radical 2 over 2. If we're doing inverse sine, which two quadrants are we looking in inverse sine? 1 and 4. That is the number one thing that is so important. You have to know your domain. Okay. When I say 4, that is negative pi over 2 to pi over 2. That's all we talked about yesterday. I have to live in between those two numbers. So where in between those two values is your y value going to get you radical 2 over 2? Quadrants 1 or 4? 1. And 1. Which one of those guys? The one in the middle. That one right there is going to have a y value of radical 2 over 2. What is that angle? That's my answer. It's just asking you, where on your unit circle is your y value going to be radical 2 over 2? And you have to live in between negative pi over 2 and pi over 2. That's the key to success. You don't have to do any of this work. All you need is pi over 4. I'm just trying to show it to you visually. Let's look at number 2. I want tangent to be 0. So I'm thinking on my unit circle. I want to know when my tangent's going to be 0. In between which two quadrants am I living in? 1 and 4. So again, I'm between negative pi over 2 down here and pi over 2 up there. I'm doing tangent. Means y over x, and I'm trying to get me 0. So where do I want the 0 to be if I want to get 0? Do I want 0 on top or on bottom? On top. So I really want the y to be 0 and the x to be 1. Show me the fingers. Where is that happening? That is out here at 0, because it would be y over x. 0 radians is my answer to that question. Number 3, inverse cosine of negative radical 2 over 2. Inverse cosine of negative radical 2 over 2. Show me the fingers. Which two quadrants am I looking in? Yeah, good finger work there. 1 and 2. Quadrants 1 and 2. I'm living between 0 and pi. So whatever answer I put right here better be a number that's between 0 and pi. I want my x to be negative. So obviously I'm in quadrant 2. So I'm out here. Quadrant 2. I want my x to be a negative radical 2 over 2. So I got 1, 2, 3 lines. Obviously it's the middle one if it's negative radical 2 over 2. Sophia, what's that radians going to be? That is 3 pi over 4. That is an answer between 0 and pi. That is the one I want. That is where x is going to be negative radical 2 over 2. Good to that point. Uno mas. Number 4. Inverse sine. Show me with your fingers. Which quadrant is your answer going to be in? I'm in quadrants 1 or 4. And specifically on this one, my answer is going to be in quadrant 4 because my y is negative. And so, again, it's between negative pi over 2 and pi over 2. And so my answer here, since I'm in quadrant 4, since my y is negative, I know I'm going to have a negative answer. It's got to be a negative angle. You can't tell me the other version of it. I need to think. All right, cool. I've got 3 lines. Which one of them is my y going to be negative radical 3 over 2? If you draw this little picture, that should be enough, I hope, for your brain to know that it's the right, which one's the correct one. I want my y to be the biggest one. It's not the middle one, because the middle one's radical 2 over 2. Which y is bigger, that one or that y value, the first or the second one? Yeah, that second one's got the bigger y value. So all I got to think about is what is that angle? Remember, it goes 6, 4, 3. So this is negative pi over 3. It is the same thing as 300 degrees. It is the same thing as 5 pi over 3. But we need to pick the angle between negative pi over 2 and pi over 2. Questions with inverse sine or inverse trig in general. Those are the basics. Today we're going to the non-basic. We're going to some composite functions. We'll make sense of those as we get going. All right. So today our main focus here is going to be composite functions, and we're going to do some inverse and some solving. But composite functions is the trickiest part of the day. The rest of it's pretty easy. All right. So the key to all of this is understanding restrictions. All right. And we're doing composite functions. So let's look at the first one. Inverse tangent of tangent of pi over 4. If they give us an angle like this, it shouldn't be too bad. So let's just do this problem. Tangent of pi over 4. That means I'm thinking about my unit circle, going to pi over 4, and I'm going to state what tangent is. What is tangent at pi over 4 going to get me? That is 1, because it's radical 2 over radical 2. This is 1. We did the inside. Now that I've done the inside, I'm going to do the outside function. So now the question is inverse tangent of 1. Or in other words, where is tangent going to get you a value of 1? And if I'm doing inverse tangent, I got to think which quadrants I live in. 1 and 4. So where in quadrants 1 and 4 is tangent going to get you 1? Pi over 4. It's basically asking the exact opposite question. What is tangent at pi over 4? It's 1. When is tangent 1? Oh, at pi over 4. They're just canceling each other out, right? It's like saying 2 squared and then square rooting. Those two things don't really matter to each other. They cancel each other out. Kind of. The problem with that is inverse tangent is mean and has, or in inverse any of them are mean. They have restrictions. And so that's not always going to be true. Let's look at the next one. Tangent of 3 pi over 4. So I'm thinking on my unit circle, 3 pi over 4. Oh, that's this guy right here. What is tangent at that guy right there going to be? Negative 1. Okay, so we did that. Now I'm doing inverse tangent of negative 1. The problem with that is which quadrants am I looking at if I'm doing inverse tangent? 1 and 4. So my answer that I found, 3 pi over 4, it's not in my good values. So my answer is not going to be 3 pi over 4 because I can't get 3 pi over 4 if I'm doing inverse tangent. That's not where my graph lives. So instead, I got to think, all right, where in these two quadrants is my tangent going to be negative 1? Down here at that spot right there, and that is at negative pi over 4. That gets me negative 1 as well. It's just in the restricted domain, and that's what we had to look at. Kind of makes sense on that first one? Before we jump to the second one, let's try A and B. Use that same knowledge here on A and B and see what you can do. All right, let's do it. Cosine, inverse cosine of pi over 6. So if you're doing cosine of pi over 6, Aaron H., what was cosine of pi over 6 going to get you? Yep, square root of 3 over 2. So right there, square root of 3 over 2, that's her x value. Once she's done that, then she's doing inverse cosine of radical 3 over 2. So, Matthew, which quadrants am I looking at if I'm doing inverse cosine? 1 and 2. In which of these two quadrants is my x going to be positive? Oh, you said 1 and 2, and then I highlighted the wrong ones. In quadrant 1, it's going to be positive. So where is cosine going to be radical 3 over 2? Pi over 6. The answer is just pi over 6. Oh, yeah, these two things canceled out because the answer that I found originally was in the restricted domain, so we were good. Let's look at B. So inverse cosine of 11 pi over 6. Inverse cosine of 11 pi over 6. So let's do that one. We're doing a cosine of 11 pi over 6. Kara, where is cosine of 11? Where's 11 pi over 6 going to be? That's in that fourth quadrant. It's that guy right there. What is cosine of that value going to be? That is square root of 3 over 2. Good. So, yeah, that's their answer right there. This answer is square root of 3 over 2. Great. We are doing inverse cosine of that, though. Okay. So if I'm doing inverse cosine of that, Sam K, which quadrants am I looking at if I'm doing inverse cosine? 1 and 2. So the problem is that answer that we have isn't in the right quadrants. So I need to take this answer and say, where in these first two quadrants is cosine going to get me radical 3 over 2? Megan, which quadrant am I looking at if I'm doing inverse cosine and it's positive? 1. And where is cosine going to get me a positive radical 3 over 2? Yeah, that guy right there. Notice the symmetry to that. That's going to be very helpful here in a second. The answer is pi over 6. Oh, 11 pi over 6, it's right here below it. Oh, to kick it up, it's just 1/6 more. Okay, it was 1/6 below, now it's 1/6 more to help us out. Does that kind of make sense what we're doing with that? That's not too bad. When I have the values, when you can just do the problem, it's pretty easy. Then we get to this example right here. So go back up to the top here. Now we're going to find inverse cosine of cosine of 9 pi over 7. So the problem here is I don't know where cosine of 9 pi over 7 is. That's not on my unit circle, so I'm in a little bit of trouble. All right, so we got to work it out here. When in doubt, graph it out. It'll help us out. Oh, I just rhymed like 7 different things. That's too much. All right, cosine of 9 pi over 7. Max, which quadrant is 9 pi over 7 going to fall into? The third quadrant. It is, boom, down there. Okay, I don't know exactly. That could totally be wrong in terms of where in that third quadrant, but it's definitely in the third quadrant. It's more than 1 pi. It's less than a pi and a half. So it's in that quadrant somehow. We're doing the cosine of that. Or in other words, I want this x value, whatever this distance is. That's the answer. Whatever that x distance is. That's the mystery number. That's the x that I'm trying to get there. I don't know what it is, and I don't really care. Okay? The answer to this question is that mystery x. That's awful nomenclature. That's an awful way of writing it, but I'm going to write it that way. Okay? It's that mystery x that I just found. Now my job is to say, all right, cool. You've got that mystery distance. When on my unit circle is your x value going to be that mystery distance? Okay? That value that we have there. Which quadrants am I looking in, Lydia, to do inverse cosine? 1 and 2. So the problem is we can't just use 9 pi over 7 because it doesn't live in our restricted domain. I need to come up with where else would this x have that same value. Well, what's true about my x value? Is it positive or is it negative? It's definitely negative because I went to the left to get there. So if it's negative, that means I'm probably going to live here in quadrant 2. When is this x value going to be the same distance? Probably like right there, right? That x value is the same distance. It's that same value as this, is the same value as all those x values are the same, but now it's in the second quadrant. What angle is it going to be if it's now in the second quadrant? 5 pi over 7. Aaron, how did you know it was 5 pi over 7? Mm-hmm. Yep, it's 2 pi over 7 down originally. So if I want to get back into the original one, I'm going 2 pi over 7 the other way. And so it's 2 pi over 7 less than a full pi. It was 2 pi over 7 more than a full pi. Now it's going to be 2 pi over 7 less than a full pi. That is my answer that I'm dealing with there. So we didn't really even care what that mystery x was. It didn't approach our problem. It just helped us to figure out which quadrant am I going to live in. Kind of make sense? I can tell you're super excited about it. Let's try letter C. Okay, letter C, arc sine of negative pi over 10. Who cares that I used arc sine? It's the same thing. So on this one, negative pi over 10. Ramon, which quadrant is negative pi over 10 going to fall into? The fourth quadrant. So fourth quadrant, I'm doing sine. And so my answer is whatever this mystery y value is. It's that's what I'm looking for. What's going to be true about that y value? Is it going to be positive or negative? Definitely negative because I'm down below. All right, great. I've got it. It's this mystery y value. Yeah, I know that's an awful way of writing it. It's a negative y value. I don't know what it is, but I'm just going to leave it that way. Then we're going to do the arc sine of that. So if I'm doing arc sine, I'm restricted to domains. Eli, which quadrants am I living in if I'm doing arc sine? 1 and 4. So it's either in this first quadrant or that fourth quadrant. Eli, which quadrant do you think it's going to be if my y value is negative? The fourth quadrant. Which angle in that fourth quadrant is going to get me the same y value as what I've drawn? Negative pi over 10. Yeah, my answer's already in that quadrant, so I didn't have to get fancy there. It's just negative pi over 10. That is going to be the right value for us there. It's a little bit weird. The more you do it, the better it's going to be. It just takes you time to get it figured out. Try D and E real quick for me. Try D and E. See if you can figure that out with your neighbor. Go. All right, let's do it. Inverse sine of 5 pi over 7. So we're going to start off with sine 5 pi over 7. Jack, which quadrant is 5 pi over 7 going to be in? That's going to be in quadrant 2. So it's that angle right there. Again, I know that it's in quadrant 2 because it's more than a half, but less than a full. I'm doing sine of that. So my sine is the y value. It's this mystery y value. I don't know what it is. Is it positive or is it negative? It is a positive mystery y value. Great. Now I am doing inverse sine of that positive y value. Ella, which quadrants am I living in if I'm doing inverse sine? 1 and 4. Good. So you're in 1 or 4. So right now our angle's not in the right quadrant. My y needs to be positive based on where it fell. So which quadrant is my answer going to be if my y needs to be positive? Yeah, but it's got to be 1 based on what you said before. You're correct though. So we're in quadrant 1. So I need to take this angle of 5 pi over 7 and put it in the first quadrant. What's that going to be in the first quadrant? It is 2 pi over 7, using the same logic that we used a second ago, that if it was 5/7, oh yeah, that's 2 pi away here, so it needs to be 2 pi away from the axis there, or 2 pi over 7 away from the axis. That is the value that's going to have the same y value as we go. It's all about, what's that word? Angles that add up to 180. What's that word? Why can't I think of it? Supplementary and complementary angles. It's supplementary here, though, for sure. Not complementary. That's garbage. We good here? Uno mas. Arc cosine. Cosine of 13 pi over 12. If I'm doing 13 pi over 12, Sam McCain, which quadrant are we going to live in? That's not 2 times around. That's like 1 and then a little bit more. So I'm really going to fall in which quadrant? Yeah, that third one right there. It's weird. I, in fact, even wrote it to be in the first quadrant, but it really needs to be in the third one. I just screwed it up. All right, so it's this quadrant right here, 13 pi over 12. That's where my answer is because it's a little bit more than a full pi. Great. It's cosine, so I want this mystery x value, whatever this is. Okay, whatever that mystery x value is. If I'm doing arc cosine, which quadrants am I living in here, Abby, if I'm doing arc cosine? 1 and 2. I'm living in quadrants 1 and 2. Which quadrant am I going to live in if I want the x value to be negative? 2. My answer is going to be in quadrant 2 because I know my x value is negative because I was in quadrant 3. So I need it to be right up here. What is that angle going to be the same as here? Anybody? It is 11 pi over 12 because it's just it's 1 pi over 12 away from the axis. Kind of makes sense on what we're doing there. It's weird. I think we're much better off than we were last period. Doing a couple extra examples, I think, helped us out a lot. All right, let's jump down to the bottom part here. The bottom part is easier. It doesn't look a lot different, but it is. Is the inverse trig function on the inside? It's a lot easier. Okay, they look very similar. You might not ever notice this, but it's a lot easier because we don't have to worry about restricting the angle anymore. All right, before we had to restrict the angle because we started with something and then restrict it back. That's not the same here. Okay, cosine of inverse cosine of negative 2/3. So it's a little bit harder in that you have to visualize where this would be. Inverse cosine of negative 2/3. So if I'm doing inverse cosine, which 2 quadrants am I living in? 1 and 2. I want the x value to be negative 2/3. So think about this. You've got a circle. Okay. That's kind of, we lose sight of that at times, but I've got a big old circle here. I want to know where in that circle is the x value going to be negative 2/3. Well, it's going to be in that second quadrant right there. Everybody know what this mystery angle is? Because I don't. I don't know what it is. I don't know what the angle would be that would get me this x value to be a negative 2/3. but I don't care. Okay? This angle right here is whatever that is that I just drew. Now my question is, what is the cosine of that angle that I just drew? That red angle right there, what is the x value that I'm going to get? The answer is negative 2/3. Because I just described the same thing back and forth. Hey, I'm saying the x value is negative 2/3 at some angle. And then I'm saying, at that angle, what's the x value? Oh, it's the same thing. It's negative 2/3. When you get this happening, where you have the inverse trig function on the inside, it's like they cancel each other out. So if I'm doing tangent of arctangent of negative 2, arctangent of negative 2, where on my unit circle would my tangent value be negative 2 if I'm doing arctangent? 1 and 4. I want tangent to be negative 2. It's down there somewhere. And then I'm asking you, all right, cool, this is my angle. What is the tangent of that angle? What's my value going to be? Negative 2. Those two things are really just going to cancel each other out. And that's all great until this next one. Don't overthink it. Oh, yeah. Here's my unit circle. You guys all just canceled out the 2, or you just made it 2? Joke's on you. Sine of inverse sine of 2. Where on this unit circle? This is the question. Where on this unit circle is my sine value going to get me 2? There you go. Doesn't exist. Because inverse sine can't get me 2. What's the biggest sine that we could get? 1. Now that looks weird because on the last one we got tangent was negative 2. Remember, tangent's not restricted. Okay? A tangent graph goes up and down forever. Oh, yeah. Up and down forever. That is different than a sine graph that lived in between that line that just went from 1 to negative 1. Everybody okay? Flip to the backside. You don't know this, but I would be your favorite teacher in the fact that I'm not going to make you do this anymore. The domain and range on these problems are awful. Okay? I'm not going to even make you focus on it. We're just going to worry about the original. So when you say thanks later, remind yourself of that. Here we go. F of x is equal to that thing right there. Our job is we are going to find the inverse of that function. Okay? We're going to find the inverse. So there are 2 steps to find an inverse. What's the first step to find an inverse? Flip x and y. My program's going to crash. Yep, there it goes. So we flipped x and y. So x is equal to cosine of y plus 2 plus 1. We flipped x and y. Once we flipped x and y, then what are we going to do? Solve for y. If I want to solve for y here, I want to go, what am I going to do first? Subtract 1. Then what are we going to do? I got to get y by itself. I want to get rid of that cosine. What could I do to get rid of that cosine? Inverse cosine. That is the opposite of cosine. That's what we just did on the whole front side. So this inverse cosine is going to cancel that out. And I get that thing right there. Then I want to get y by itself. So what else would I have to do? Subtract 2. My answer is inverse cosine of x minus 1 minus 2 is equal to y. That is the answer here. Everybody kind of okay with that? Let's just look at the domain and range. I'm not going to make you solve it. It gets kind of bad, okay? It's a little bit harder than you want it to be when we graph this thing, okay? So originally, what did we say? It was cosine x plus 2, and then it was minus 1, or plus 1. Okay, there's my original graph. What's the problem with finding the inverse of this graph? It's shifted, but it's also not 1-to-1, remember? And we talked about that if a function is going to have an inverse, it needs to be 1-to-1, okay? So the answer of the graph that we just got is that little red line right there, okay? Arc cosine of x minus 1 minus 2. That looks way different than my blue line because it's restricted, okay? If we look at the range of this graph, that would have to be the range of this one. And so we're not going to do it, but the range would be -2. I think I gotta hit a colon there. Sorry. No, I used the wrong thing. I don't remember how to do Desmos. I used to be good. Oh, it's that guy. There we go. It took me 10 minutes to remember it, but I just remembered it. All right, cool. That's the restriction that I would have to have. See how now they are both one-to-one and they're both functions? It's the idea of switching the domain and range, okay? This original graph, it lived between some different values, and I'd have to go back and forth. And so know that there is more to what we are doing, but we're not going to necessarily go through it. It gets a little bit funky, okay? But the domain and range aspect of it's important because otherwise it wouldn't be one-to-one. Find the inverse function of this guy right here. Go. We are finding an inverse. Kara, what'd you do first? Yes, you did. X is equal to 3 sine 2y. Then what'd you do, Eli? Yes, sir. Divide by 3, divide by 3. That cancels. We get x over 3 equals sine of 2y. Then what, Jack? Inverse sine. Oh, no, I wrote the word arc sine instead. How is that different than inverse sine? It's not. So we have arc sine of x over 3 equals, over here, these two things are going to cancel. 2y. And so to finish, obviously, I'm going to divide by 2. Make sense on that one? Inverses are easy. It feels a lot more like regular math than what we were doing on the front side. And I know the front side's a little bit bad. All right. At the very end, it's the same thing. Now we're solving trigonometric equations, okay? Instead of finding the inverse, we're just going to solve it. We are just trying to get x by itself. Notice that there's not two variables here. There's just one, okay? So I'm literally just trying to get x by itself. So Ella, if I want to get x by itself, what do I need to get rid of first? Yep, let's get rid of that 6. So we're going to divide both sides by 6. I get inverse cosine of 5x equals pi over 6. Okay, so we got rid of that first. I'm still trying to solve. So if I'm still trying to solve here, Lydia, what could I get rid of next? How do I get rid of that? Good. I'm taking the cosine of both sides. Because when she takes the cosine and inverse cosine, notice which one's on the inside. Inverse cosine is on the inside. Oh, yeah, that's easy. I don't have to worry about restricted domains. Those two things are just going to cancel. And then cosine of pi over 6. What is the cosine of pi over 6 going to get me? Yeah, I can just write in that number. It's radical 3 over 2. It's just unit circle. Boom, boom, boom. Pi over 6 is right there. Oh, yeah, it's x value. It's radical 3 over 2. And then I want to solve. So what else do I got to do to solve? Divide by 5 or multiply by 1/5. Same difference. So x is equal to radical 3 all over 10. That is the answer. Very much just normal, good old solving math. Okay? It's good stuff compared to some of the other things that we do in terms of that it's not high level stuff. It's just add, divide, multiply, inverse cosine, whatever you got to do. Make sense? Try B. Go. Good. Let's do it. Matthew, what did you do first? Yes, sir. Divide by -4. Divide by -4. That goes away. Then what'd you do? Tangent of both sides, because tangent and arctangent are going to cancel. And then he's doing the tangent of -pi over 4. And so tangent of -pi over 4 there is -pi over 4 right there. What is tangent going to be down in that quadrant? -1. X is equal to -1. That's my answer to that question. Yes, sir.
So in problems like that, would you give us certain things like on the front side where we have to find like restrict the domain and then find the value and then solve for x?
On those problems?
Yeah.
No, those problems are very straightforward. They're just solving.
Okay.
There are times when we will solve later on. You're leading us into section 3, where we will solve a problem like this, like cosine of x equals 1/2. If I were to say solve that for x, there are infinite amount of answers where cosine is going to get you 1/2, right? 60 degrees, 420 degrees, add 360 again, add 360 again. In that case, yes, I will restrict the domain because otherwise you will go forever and ever and ever. But on these questions, it's going to, if you're solving an inverse cosine, it'll be very straightforward. There'll just be one answer. Any other questions?